So, okay, I think we can start because it's 10:02. People will arrive. So, good morning, everyone. Thank you for joining this session. Today is the second day of this global LGN Global Connection, very successful so far. I am Monica Rossi. I'm a professor in Politecnico di Milano University in the Department of Management Engineering, as well as a partner of the collaborator with the Italian Institute, Lean Italian Institute. And together with me today, I am introducing you the speaker, is Cevdet Ozdogan. He has a huge experience on, I think he's the most knowledgeable person I know on lean product and process development. He has lots of experience starting from Japan and actually all over the world, I would say, not just Europe, but the world, applying lean product and process development in different kind of industries and organization. Today, Cevdet is going to talk with us and to tell us how to create reusable knowledge in product development, as you know, is crucial. And we always talk about reusable knowledge, but that's also the most difficult aspect that not many people actually are able to tackle, as Cevdet is able to, and correctly using the right knowledge. So we have this very interesting presentation for today, and I'm leaving the stage to Cevdet now. And sorry, before we start, I'm asking everybody, please drop questions in the chat. So feel free to ask as many questions as you want in the chat. I will be reading and addressing the question together with Cevdet at the end of this session. So feel free to write the question, and don't worry, we will have time to discuss at the end. Cevdet, the stage is yours.
Yeah, thank you, Monica. Hello, everybody. This is second day. Actually, it's the second day. It's the continuation of 24 hours, but we go to bed between them, so that's why we second day for us. So today I will talk about for a little LPPD, and then what does it mean creating reusable knowledge in LPPD. So actually, the informations and examples in this presentation, some of them are taken from the books and presentations of Jim Morgan, Doris Sobek, and some other areas. Some of them belongs to my former experience in Toyota. So let's see. So how we explain the LPPD in general, actually we describe it like a house. So then from the strategy of the company, it comes first as develop the right product. If the product is not right, then how successfully you develop the product, it doesn't matter. So in order to keep this roof, we have two columns in the center of the house. That one of the column is that the effective product development, we call it method. So today, the presentation is more related with this, how to make the effective product development. And another one is that correct management system in product development process, how to manage the process and properly. And of course, related with another column is that people development to make the people side. So when we create them all in a correct manner, that all should be based on the basement actually is the learning, developing a learning lessons from the mistakes and create a learning system. So that's the general approach that how we are looking the LPPD. So then if you say, what is the LPPD? LPPD is a system which meets customer real needs by providing profitable operational value streams without having any waste, and with sustainable approach. So LPPD requires to manage two value streams at the same time. One of them, everybody is focused on value-adding product development steps to complete the product design and realization. So normally everybody is focused on the realization of the product development. But at the same time, we need to have another value stream, creating reusable knowledge and learning continuously. So we can say we don't need to rediscover the wheel again every time. So how we can use the knowledge improperly and to make the knowledge company's knowledge, not the people's knowledge in their brains. So because in many product development experience that we are meeting that people has the experience, but company doesn't have the same experience. And people, they keep their own experience, then we have a huge difference in the applications. So in many companies, we have done some research that even some simple bracket, in the machine companies, for example, they are building, they have a simple bracket similar to each other, but every time the location of the hole from the side was totally different than each other. Every engineer designed it in a different way. So what should be the correct way? We don't know it. So then how we can standardize and apply, create a reusable knowledge? It's to make it time effective and right products on the right time. So in order to develop the effective product development, we have actually 5 major approach. One of them is trade-off curves, knowledge curves. Probably, I will shortly explain it. Another one is the design standard, design guidelines, which is very critical to make it. Then the third one is the design for sets and standardization. Today, I will shortly mention about the first 3. Then, of course, we need to have, if the product is not known very detailedly for us, if it's a new concept, new design, then we need to have gradual convergence, a set-based concurrent engineering. So then we need to have fixed and flexible sites, because if the product requirements, if customer requirements is not known by us, we haven't got any experience in design before, there's no standard for it, then we need to new design sets to realize it with the concurrent engineering. Otherwise, we can follow the standards, what has been done before. And the 5th one is giving the late decisions, feasibility before commitment. We say compatibility before completion. So then what is the trade-off curves actually? Maybe we can ask some questions. How we can convert data to reusable knowledge? Because we have too many information, too many data, but does it mean that it's really knowledge? And how we can use them again? How do we design the product not to have any problem at the customer during the production process? So this is also another problem we need to solve it. How can we stop the waste of not using the available knowledge and rediscover again? How can we optimize the design? That's also a problem we need to solve. Then how can we be sure about correct activities of suppliers? Are they standardized in activities? How can we understand the customer needs even better than the customer? And how can we assure the easy manufacturability of designs? Should be tested everything every time. So one of the good solutions is the trade-off curves. So if this is some simple curve, then if 2 varieties, for example, the pressure drop and the noise level, then if the pressure drop high, noise level increase, then we can have a curve. For different sizes, we can have different curves. So here we can see which area is the safe area and which is the dangerous area. We need to be sure. So the curve changes 2 varieties at the same time, how it's affecting each other. So design decisions could be given with given data. But the point is that how we can have this data. Because that's why the management's role is to prevent giving the product design decisions without having sufficient data by everybody. So how we can assure it? Normally in product development, we have a system and procedures and test data. We do in vehicle design, we do road tests, we collect the data from the roads, applications, and we create test procedures. And whenever we design a part, an axle, a spring, or a bracket, we test according to the working conditions, according to the procedures. Under this load, with this frequency, we said that it shouldn't be broken. Then after test is passed, then we say design is okay. But we don't know maybe design is over design. If it fails, then we make it a little more stronger, try to pass the test again. So then it's pass, test, pass or fail. If fails, redesign and test again. So then in the end of this application, we don't create any knowledge. We have the very good test procedures, but we don't have anything learned from this one. And in most of the cases, from my experience, I did in several times, you are in under stress of time and it shouldn't fail. Generally, we have the tendency to make over design, which means extra cost. Then we test the procedure according to procedures. It doesn't fail. We said we did a good job. But what did we learn? Then the question comes, how we can make a design and assure even without testing? We don't have the answer normally. That's why we have the trade-off curves. Whenever we test and it fails or doesn't fail, that's a different approach in Toyota. Toyota generally tests until to break. When we break it under these working conditions, with this load, with this frequency, then we understand where is the failure mode and what's the limits. We try to understand the limits of every design. Then in this graph, we put a stop point there. Then we can do another load, another working condition, then test again. Then we put another one, then another one. Then in time, we can have a graph. Then we know that this is the safe area and this is the weak area. So how we can use it? So it means that if we can know what are the loads and the life of the cycles, and then what's the correct graph? Because there's a formulation actually. Then when we have this graph and when we assure with the test, maybe with the different thicknesses, we can have the same thing. Then for each thicknesses and each different loads, then we can decide for next time, according to this graph, we can decide what should be the correct thickness and correct load and life expectations, which type of material or which type of thickness we need to select. Then we can be sure that this will be right in the first test. Even we can combine some of the tests and eliminate the number of tests. So that's the purpose of the trade-off curves. With some chains, we can make a design, a graph, and then this can be used by anybody else. So even without less experienced people. So same thing in production side we can do as well. So when we make a sheet metal or fender, then we know that what are the limits for easy manufacturability. If we have over these limits, we can have a crack, or we can have more scrap during the pressing process. So from our experience that we know that here's the safe area and here is the dangerous area. So if we know this information, if we create this knowledge, then next time we can have more effective designs and spend less time for it. And at the first time right in the design can be more easily achievable. So that becomes a good experience for the working conditions, and even for manufacturing limits, we can use it. So how we can make it? We can generally prepare it in A3s. Then we put a drawing and the drawing of product and process, explain or focus failure modes, for which failure mode we are preparing this A3, and a kind of root cause analysis. What are the possible root causes of these failures and possible countermeasures? And then this curve showing the parameters of failure occurrence. For example, design of a forming process. Between those two diameters and stress level, when this radius and the ratio between the radius and the forcing process, we need a graph. If this is not good, this dimension requires, the ratio of this dimension requires different force and temperature for shaping. So according to the experience, what we realized, if we can turn them into a graph, then means that we have accumulated our knowledge. Then we can have a design process for forming all knowledge and informations. Actually, this data is a kind of formulation. So from our experience, we can prepare an A3 document like this and put all our knowledge onto this document, formulation and testing and real experiences. Then anybody can use for a new designs. So who should prepare these documents? Actually, in Toyota experience, that's the job of the most experienced engineers. So normally I see in many companies that the most experienced engineers are given the difficult job, difficult design process. But normally we propose them not to do the designs, not spend their experience for the standard designs. We need to use their experience as to create more knowledge. So that's why when the most experienced engineers, when they create the curves like this, then anybody can use them easily. So their graphics is the key for showing knowledge. It shows the limits to be done with a certain technical level, and this drawing can be done with the formulation or a kind of simulations from all experiences. Maybe you can think that we are spending time for it. Yes, at the beginning we may spend some time, but when we found the graph, when we prepare it, next time we can continue the design with more effectively, always first time right, and in a shorter time. And you can also prepare this knowledge even in time. But just the critical thing is that, are we testing them just to assure the pass the test or fail the test, or trying to understand the limits? Whenever we understand the limits, we are in the position of creating the curves and the graphics. So design team can also prepare engineering check sheets to use during the design review while summarizing the key points of the trade-off curves. So it makes the job easier. How we can make it? Please start to prepare with workshops with the help of experienced engineers if you didn't start earlier. So new engineers can start to prepare by themselves after getting experience. So that's the role of most experienced people, and they need to create together with the other engineers. These curves are prepared by the engineers who are using them in time, putting the dots and accumulating the experience they are having it. Then first focus the certain failure modes. Then you can read more than information into the same page. It becomes a guideline and to support understanding and learning and teaching and remembering to each other. And in order to evaluate suppliers and their design confirmations, and with this type of experiences, without reinventing the wheel, we can reach the zero defect easily, even without doing the test. And we can use to convince for an idea. So with these trade-off curves, even less experienced engineers can solve the problems. In classical approach, engineers have an idea, they do and test and fails and do again. So, but with the trade-off curves, with the lean thinking engineers, with the usage of best performing trade-off curves, understand the limits and stay safe and assured area. So even in production, in testing, you can use the similar curves easily to be always in the safe side. Actually, this is used in airplanes long time, so this is not a new information, because when the testing in airplane, it means that if you fail, most experienced engineers, you can lose it. So that's why they tested profiles, they did the graphs, and used more successfully in different airplanes, still in use. So another one is that to keep the knowledge is the design guides and criteria. So what are the design criteria? From the former experiences, what we have done, we can put the design rules and engineers follow the rules and the learnings, this one. So it helps us to eliminate repeating mistakes, to standardize designs to reduce the cost, investment, testing, lead time, engineering time. So we can have more effective engineering, and we can record the knowledge and experience from people to make the assets of the company, not the people's knowledge. So you can see some examples. Even simple details we can standardize. So even the vehicles can be different, even each brackets can be different, but we can use the same details. So you can see another example. So all experiences we can put into some design guides, design criteria. Then every different design, we can use the same concepts for every product, which are proven design standards. So when anybody can use the same standards, even less experienced people can design the products without any failure. So it contains many deep details. Then you can easily standardize in a proven way for easy manufacturability, perfect cost, and perfect design results. So some different examples we can see it. And at the same time, we can easily review the design. And if we can make the design criteria correctly, we can eliminate this kind of interface and get rid of them with some design rules and design standards. We can easily eliminate many problems. Yeah. So another point is that if we can use the standardization, how we can use the standard design sets or standardization, especially even the market variations. We can have different market variations and some design uncertainties. We can put some different standards in the products so they can help us to reduce the cost and the other things. For example, even the shape of the fenders can be different, but the details, we can use the same standards for easy manufacturability. Or we can put the design for sets and standardization. So is it possible to use the common parts? Or maybe if not possible, sub-elements we can use as standard. So that's why, especially with the TNGA, Toyota TNGA, we try to eliminate unnecessary differentiations. Then more standardizations became like this. So every time we look at that, can we use the current main part as a standard? If yes, it's good. No, then we go to the next one. During new design, which sub-elements need to change? Okay, this sub-element need to change. If it's like this, can we make the others standard? Can we use them as common? So if we can have a new design, this time then we can return to first question. The new parts can be used instead of other parts as standard again. If again, no, it should be totally different. Can we use the sub-elements as common? Some sub-elements, can we use them as common? If it is still no, then the last thing is that can we use the same tooling to make it? So if we can create this kind of standardization, it helps us to keep the knowledge and to use this knowledge again in every new products as a part of the designs. So Monica, I try to go as fast as possible, but I try to put many informations. I hope that everybody understood easily. So I stopped a few minutes earlier that if there's a question,
yes, we have already some question, and we hope that more questions will arrive. So Alistair asks, are there trade-off curves applicable in designing services?
I don't have the experience, but I assume it's possible. For example, design curves or a kind of standardizations maybe we need to think about. I really don't know. I haven't experienced. But in the service industry, it sounds to me to have more standardization. But if there are some different varieties, affecting each other, I assume it may be possible. I didn't think about it. Why not?
Yeah,
It's a good
I
question,
also assume
Alistair.
I also assume it's possible. I mean, whenever trade-off curve puts together in the same, page, how one variable change when other two or one
Yeah.
changes, that's even possible if we consider as a service like a dimension of the number of customer we can serve or other variable. I think we can always think about two things that as one changes, the other changes, and a relationship between how these two changes between each other. So maybe something not measurable like a physical dimension, but for sure, if
I
someone has
think
experience
I
with
think
that,
can
would
be
be
done.
nice
Yeah,
to
I
see.
think can be
I
done.
think so.
But yeah, maybe we need to work on it. It's a good point, Alistair. Let's
Very,
work on
very
it.
nice. And similarly, someone is asking if we can apply the trade-off curves to software design.
I assume in the software design, the similar experience, because software is also a kind of production, because we write the
Yeah.
codes, and some working and non-working areas, some experiences we have gained, and some limits that we found that they are failing. I think we can put onto some database and create a kind of graphs or checklists. Can be done. Good ones and failed ones. We can put the limits.
And someone is suggesting the best representation for knowledge management, in my experience, is Nonaka's matrix. Is it also applicable in this process?
I don't know. Do you know?
Uh,
Do you have?
so we have additional feedback on that. Is like knowledge is initially implicit in some people. What can be the key points to allow this to be initially shared and then transformed into trade-off curve? I think the key part is the soft skill and the emotional environment in which people work.
Not only this one. I had this experience in many times in the companies that even in professional life we have seen that the most experienced people are the most busy people. So we need to take out them from standard process. So of course, people behaviors are important, but management commitments is also very important. And then how we can use these people not to make the design, to create this kind of knowledge curves and design standards, and we need to convince and explain them the importance of this new job. So that's
Yeah,
why we have many experiences like this. We have done several times. But management commitment and taking the risk is also very important.
thank you. And that he is the same person who was mentioning the Nonaka's matrix about how we make knowledge explicit. But Nicole, in this case, Chef, that also with the trade of curve, we also go into the detail of the relationship of the variable. So something that also
Yes,
supports.
we need to have minimum two variables, around 2 to 3 variables. We need to put the relation with them, and there should be a technical relation as formulation or simulation. We need to create the curve.
Exactly. And this is very useful to support designers and engineers, but not very diffuse, I would say, inside the company. Indeed, Alistair proposed in the software maybe complexity of code versus bugs. You see, these could be two variables that could fit.
Yeah,
Exactly. Murat says, thank you. We learned that standardization is as deep as we dive. Standardization of standardization. Yeah, infinite
yeah. We can put
standardization.
into different levels.
Yeah. And other questions? I know that we are we just filled the time. We have claps for you. I think this is very interesting topic. Whenever I go to company and try, to go in depth, the knowledge management, it's always very hard because then we go to knowledge is implicit, or we always did like this. We have this experience. We have the project somewhere, but it's very hard to find some a company is structured in a way that they are able to reuse knowledge and learn from
Exactly.
the past and be, not making the same, as you
Exactly.
were
And
mentioning, not reinventing the wheel. And many times companies reinvent the wheel.
there's an interesting thing when we use them in many LPPD applications. We of course set-based engineering. So where is the limit? When you follow the standards and design guides, then when you pass the set-based engineering, so that's also a decision point. So where is the limit? So that's why it's fixed and flexible.
Yes.
So that's why in the product development, we divide the products in different range. For example, we call A-type product, means that we know how to design and how to produce. B-type product, A-type product, we don't know how to design and how to produce. But when we say C-type product, we know how to design and how to produce. So when we have, it's a full change, facelift, for example. So then you can use the design change as standards with the standard knowledge. But if it's a really new change, new customer requirements, we don't know anything about it. We have never done before. Then we need to design sets because we cannot use the current standards to make it. So that's why we need to describe the limits where we can use the trade-off curves and design guidelines and standardization, where we need to change to design sets and set-based engineering activities, how we can combine them. That's very important as well. That's why we say fixed and flexible in the product development.
Totally. This is very inspiring, Chef. That how many of you guys from the audience are applying or did at least try to apply set-based concurrent engineering?
Monica has a very nice simulations.
No, okay. But I mean, I always mention the thing that you just mentioned about which is the Alistair is just learning. Where should we, because it's an investment, not a waste, an investment of time sometimes to apply set-based concurrent engineering. So for fixed knowledge, we could go for the standard that we have, and for the flexible knowledge, we can go and explore with set-based concurrent engineering. But that's a challenge. And we invite you guys from the audience to share with us your experience, if you have, in this term. So either trade-off course, but also set-based concurrent engineering experiments. And if you want, you can keep in touch with Chapdet and myself, and we can keep discussing about the topic, because it's really challenging. So thank you, Chapdet, for being here. Let's take a picture.
Yes.
Thank you, Chapdet, for being here. Thank you, everybody, for being here. If you want to keep in touch, there is also the possibility to send private messages in the list of, you just go to event, you just identify the name in the list of people.
I'm writing also my mail address. People can contact
exactly,
me if they
you
want.
don't mind. So you can write your email there. So guys, just take the email and talk with the Chapdet. Great.
Okay.
Thank you very much.
Thank you very much.
Thank you. Bye.
Thank you.
Thank
Bye.
you.